Hi there. Today we're going to start a new unit and talk about algebra concepts. Algebra can be a big scary word, but really it's not. You've actually been working on algebra for many years. Algebra is when there's something missing in a problem, in an equation. We've been working on missing pieces or parts of an equation since we were in first grade, so it's actually not as bad as it sounds. Okay, whenever we're talking about algebra, lots of times we use a symbol to show the part that's gone that we're looking for. So let me give you an example, okay? You in first and second grade saw equations that look like this. 5 take away something. The box is the unknown. It's the part we don't know that we're going to try to figure out what it is, equals 3, okay? So algebra, now that you're in when you went to third and fourth grade, instead of using a box to show the part that was not known, we started putting a symbol in there, okay? And what's really sometimes confusing is lots of times we use letter symbols. So we're going to make an N, okay? I just picked any letter of the alphabet. 5 take away N. N means something. We don't know. It just is showing us there's something that we don't know right there. We know it needs to be a number, and we're going to use the N to show that we're missing something. 5 take away N equals 3, okay? So whenever I use a symbol like this, it kind of makes it an algebraic equation, okay? Because it means we're going to try and find what N is equal to, okay? So we could solve this pretty easily. We could grab the 3 and count up, 3, 4, 5, or we could grab the 5 and go down, 5, 4, 3, 2. Either way, we could solve that N is equal to 2, okay? That's a real simple way of building up to algebra. But now that we're in fourth grade, we're ready for a little more difficult algebra, okay? Not scary hard, just making you think a little bit more about your math, okay? Here's one that we can look at, okay? It's N plus 5N equals something. Now you might think, oh my gosh, I can't solve this. There's 2 letters in that one. That might seem a little overwhelming, a little scary, right? I'm going to move that so you can see that better. But really, we only have one number in this entire expression, and that tells me that we aren't going to be able to solve. Before we start trying to solve for the number, now that we're in fourth grade, we need to just think about what the expression is telling us, okay? We have something, we don't know how much it is. And if we add it to 5 times that amount, we're really adding another N to this. So if this is 5 N's and we add another N, it won't be 5 N's anymore, it'll be 6N, okay? We know that when the 6 is next to this one, it's meaning time. So 6 groups of N, 6 N's, okay? When we talk about using this kind of algebra, we're talking about the identity property. The identity property means you're looking at an expression and you're not really solving for the unknown. We're not trying to find out what N means in this one. We're just trying to make it simpler. So instead of writing it all out like this, we could say, oh, if I put one more N with 5 N's, I'm going to have 6 N's. I simplified it. Let's look at another identity one, okay? This one's pretty easy. Okay, so we've got 8F plus F plus F. So we just need to simplify this and figure out what it's trying to tell us, okay? We have 8 of something. If we add another something and another something, we could write this in an easier way. So we had 8, add on another is 9, add on another is 10. So we could simplify this by saying we have 10 of the unknowns, okay? 10 groups of the unknown. Let's look at one more. See how the identity one, we're not solving for numbers, we're just simplifying. Okay, now we've got a bigger number in here. Let's not get scared by that bigger number. Again, I'm going to move this for the glare so you can see it better. We've got x plus 245x equals what? Just because the number's big doesn't mean I should start worrying that I can't do this problem. I just have to think through what it's telling me. We have 245 of something, but I want to add one more to it, one more of those somethings. So instead of 245, I'm going to have 246 of that unknown, okay? That's the identity property. The identity property means you're just simplifying it and you're actually not finding out what it is. You're just simplifying. Okay, let's go on now to, before we go to the commutative property, let's talk for just a minute about any problems that have these in it. If you remember what these are called parentheses. Parentheses mean do me first. If you have something inside of here, you know you need to do this part of the problem first and then do this part. So we'd say 5 plus 3 is 8. I might even cross this out because this whole thing means 8. If I put them together, I get 8. So now I have 8. Now I can finish it. Take away 1 would equal 7. So parentheses can be another way to simplify a problem. All of this is a kind of algebra, okay? So parentheses, if you see them in a problem, you're always going to do those first. I like to put some rules down to help me remember about the order that I'm going to do problems when there's parentheses, okay? Parentheses always go first, so you're going to do your parentheses first. If there's no parentheses, then you have to think about which math makes sense to go first. So you might have a problem like this. Let's see. Okay, we have to think about this problem and decide what has to be done first. Well, the multiplication has to be done first because because this is going to be my whole quantity, and then I'm going to take something away from it to get my solution. So we're going to do the multiplication or the division first. First we do parentheses. If there's no parentheses, then we do multiplication and division. Then if we're done with that, then we might do subtraction and addition. Okay? So 3 times 8 would be 24. Take away 1 would be 23. See how I'm still simplifying the problems, doing a small part first so I can finish it and get a solution. Okay? We have reviewed this order in 3rd grade. We learned this in 3rd grade right here. And we're just reviewing it today to help us remember, and also we're reviewing the properties. Going to commutative property. Commutative property means you can switch things around. So that would be like 3 plus 2 equals 5 is the same as 2 plus 3 equals 5. These are the parts. You put them together to make a whole. So if I made a picture of this, my whole number is 5. My parts are 3 and 2. It doesn't matter which one goes first, 3 plus 2 or 2 plus 3. When I put them together, it's always going to make the same total 5. That's the commutative property. Commutative property also works with multiplication. So if we turn these into multiplication instead of addition and did 3 times 2 equals 6, the commutative property says we can switch the factors around and do 2 times 3 and it will still equal 6. Okay? So the commutative property is showing us that with addition and multiplication you can change the parts order or the factors order, and your product or your total will stay the same. Okay? Let's take a peek at what happens if we look at division. Okay? We know that the division means you're taking a whole amount and you're fair sharing it. So can we switch the order of division? Well, let's look at that. If we have 16 divided by 4 equals 4. Can I change the order around and still have the same ending? Let's see. 4 divided by 16 equals 4. If I take 4, can I share it to 16 different people? No, because I don't have enough. I only have 4. So we actually cannot use the commutative property with division. We cannot use it with division. Let's check it with subtraction. We've got 16 take away 8 equals 8. Can we flip these two around? 8 take away 16 equals 8. Can I have 8 and take 16 away from 8? No, I can't do that because I only have 8. So what I'm discovering and remembering is that the commutative property works with addition or multiplication. It does not work with division and subtraction. It only works with the math things that are putting things together to make a bigger total. Let's go to associative. Associative property means you can move things around and do them in different orders to help them make sense. Okay, let's come over here to that one. Associative property looks like this. Now, I'm going to use letters on here. I'm not going to use numbers. And just for a minute, just look at the letters and don't think about trying to solve and figure out what those letters are. Just look at them and think about simplifying them, okay? So we would have A plus B plus C equals, I have a big mark on my board, so I'm going to scoot this over so we have more room. A plus B plus C equals okay, again, we're not looking to solve this. We're looking at the fact that we have an equal sign in the middle, and the equal sign tells us that everything on this side of the equation has to be the same as everything on this side of the equation. And that can be kind of hard to remember. Sometimes I take a piece of paper and I look at one side at a time, okay? So if I look at this side, it's telling me that I have something plus something new, because this is different, these two are different, plus something else that's different. The parentheses are telling me to do this part first and then add that, okay? I want to see if this could be written in a different way and it would probably give me the same result. Okay, remember we're not trying to solve for who's A, B, and C. We're looking at whether the order and the associative property would work. Okay, let's flip it over here. Now I've got A plus B in parentheses going first plus C. So what I need to ask myself is, if this math operation, adding, if it will allow me to change the order of who I do first. Since it's adding all the way through, all the way to the equal sign, and all the way on this side of the equal sign, I know that my commutative property tells me I can do adding in any order and it won't change the result. So I can group these two together first, or I can group these two together first, and it's still going to give me the same product. So the associative property means I can group some of them together and it won't change my product, okay? That means you can decide what's easier for your brain to do, okay? But only if the math that's happening in here, see how it's all adding? Only if it's a math that works for that. If we were to change that math to multiplication, could we still do it? Could we still group these first this time, and then take it times that, these first, and then take it times that? The answer is yes. It's very similar to the commutative property. The associative property works really well with addition and multiplication. Let's try it with subtraction and division. Now we're talking about something completely different, because this take away this, we would group those, we have to group those based on who is the bigger number. Because if this number is smaller than this one, then they can't be grouped together, because you can't subtract something smaller. You can't take something bigger away from a smaller number. So the associative property is not as flexible, you can't do as much with it when you get to subtraction and division quantities. So I see something that's happening that makes me think of these two being similar. They can do the commutative property more easily, and they can do the associative property more easily. Okay? The identity property can be used with addition, subtraction, multiplication, and division, but these two properties are used more easily with addition and multiplication, which is probably why first we do parentheses. The next easiest one is that multiplication and division, and then subtraction and addition.